The height of a circular cylinder is 4 times its radius. Find a function that models its volume V in terms of its radius r. Find its volume if its radius is 2 inches, round to the nearest tenth of a cubic inch. Find its radius if its volume is 200 cubic inches, round to the nearest tenth of an inch. Now, a circular cylinder is basically the shape of a can of soup. So problems like this might be particularly useful to food industry manufacturers. So we are wanting to look at the volume in terms of the radius. So a circular cylinder will have a radius and then also a height. And the formula for the volume is basically the area of the base times the height, and because the base is a circle, it has area pi r squared, so that's the area of the base times the height. So we've got pi r squared h. But we want to write this as a function of just the radius, so we need to express the height in terms of the radius. Luckily, we're given that right away. The height is 4 times the radius, so we can rewrite the height as 4r, and we can move the 4 out front, and r squared times r is r cubed, so the volume as a function of the radius is 4 pi r cubed. All right. So that is our function that models the volume in terms of the radius. Now we're asked to find its volume if its radius is 2 inches. Well, all that's asking us to do is substitute in 2 for r. So that's going to be 4 pi times 2 cubed. We know that 2 cubed is 8. 2 times 2 times 2. And 8 times 4 is 32, so we get 32 pi. Now, we were asked to round to the nearest tenth of a cubic inch, so if we use a calculator to get an approximation, this is going to be approximately 100.5 cubic inches. We can also write this as inches cubed. Both of these are fine ways to write cubic inches. So if, for example, these are cans of soup, and we know that families will be happy with a can of soup that has a radius of 2 inches, maybe that is something that's appealing when it's on the shelf, and they're willing to pick up a can that's that big, they need to know how much soup they can put in the can. And so in this case, it's 100.5 cubic inches. So these questions may seem pretty random, like find the volume if the radius is 2 inches, but these end up being very useful in manufacturing. Let's look at the last part of this problem, find its radius if its volume is 200 cubic inches. So in this case, it's the volume that we're going to be replacing. So we have 200 equals 4 pi r cubed. And we need to solve for the radius. So to get the r cubed alone, we can divide both sides by 4 pi. Now 200 over 4 can reduce by a factor of 4. That's going to be 50 over 1. So this just becomes 50 over 1 pi, or 50 over pi, is r cubed. And if we want to find the radius from the radius cubed, we need to take the cube root of both sides. That gives us r on the right, and then the cube root of 50 over pi. Now this is our exact answer in inches, but if you go to someone working in a factory and say, I want you to build a can that has this as the radius, they'll look at you like you're crazy. They need just a number that they can easily type into their computer or that they can easily look at. So we can use a calculator to get an approximation for this. And when we do that, we can see that the radius is going to be approximately 2.5 inches. So that is our approximation for the radius that gives us a volume of 200 cubic inches. Again, perhaps the manufacturing company recognized that this is the volume that will give them enough soup for 2 servings. Let's say they're advertising this soup can that has 2 servings, and so they know they need to make the radius 2.5 inches to make it work out.